Okay, let's continue. After you have plotted the particle size distribution curve, based on this curve, you can now identify the diameter of the percent finer. So let's identify the diameter of the 60% finer, diameter of 30% finer, and diameter of the 10% finer. So to identify those diameter, you simply have go to your particle size distribution curve. Based on the particle size distribution curve, you have here your, this is the particle diameter. So this 60, meaning to say you're going to locate on our y-axis our 60% finer. So D60 represents 60% finer. We're going to solve for the diameter of the 60% finer. To solve that diameter, you have to locate first the 60% finer. So this is 60. You draw a line horizontal. It should touch the particle size distribution curve. As it touches our particle size distribution curve, you draw a line downward, and it should touch our x-axis. So once it touches our x-axis, you read that approximation for the diameter. So now, once you have read that one, that is now your diameter for the 60% finer. And for that, approximately, that is equal to 0.41 mm. Then how about for D40? So you move on to 40% D30. For D30, you move on to 30% finer. So approximately, it is located here. You draw a line horizontal, and it should intersect with our particle size distribution curve. You draw a line downward, then you read this particle diameter, and that is now the diameter of the 30% finer. Approximately, that is 0.185 mm. And the last one is D10. So D10 is here. So this is the 10% finer. You draw a line horizontal, and it should intersect with our particle size distribution curve. So on this intersection, you draw a line downward. So that is now, you read this particle diameter. So that is now, that corresponds now to our diameter for 10% finer, and approximately that is equivalent to 0.09 mm. So after you have identified the diameter of the various percent finer, then move on now to one parameter, which is the uniformity coefficient. So the formula is D60 over D10. You simply have to substitute the value. So that is 0.41 or 0.09, give us 4.56. And the last one is the coefficient of gradation. So this is equivalent to D30 squared over D60 times D10. You simply have to substitute the given values that we have identified a while ago, and that is now equivalent to 0.93. So that is now the last topic, which is the particle size distribution curve. So I just hope that you have understood and grasped the concept and principles on classification of soil, which is important as we have to use some parameters in the analysis and design of a certain structures. Thank you.